Good day, guys. Here's another video for the work energy and power on vertical motion. During the fire extinguishing operation, a helicopter remains stationary, hovers above a dam, filling a bucket with water. The bucket of mass of 80 is filled with 1,600 kilogram of water. It is lifted vertical upwards through a height of 20 meters by a cable at constant velocity of 2 meters per second. Guys, here this helicopter is stationary and it's filling up a bucket of 80 with 1000, so we must combine that mass is going to be 1608. It's very important. So this bucket is lifted vertical upwards to a height of that, which is our displacement as well, and it moves at constant velocity. That's very important. The tension of the cable at 17,000. Assume that there's no sideway motion and air friction is not ignored, right? Now state work energy theorem. The work energy theorem, it says the net work done on an object is equal to the change in kinetic energy of an object. 5.3. 2. Draw a label free body diagram showing all the forces acting on the bucket while it's being lifted. So let's draw that. 5.2. Very important. Dot represent the bucket. And then there's a tension force upwards. And then there's a gravitational force downwards. And there's a friction force downwards, which is the air resistance there. Right? It's very important. There are three forces acting there. The last question, it says use work energy theorem to calculate the work done by the air friction on the bucket of water after moving through the height of 20 meters. Right? 5.3. We're going to use the work energy theorem there, which is we're going to do the net work done of the forces that are acting there, the work by friction, the work by gravity, plus the work by tension force is equal to the change in kinetic energy. The change in kinetic energy is going to be 0 because it's moving at a constant velocity. So work done by friction, cos theta, and then it's the work done by gravity. The work done by gravity, it's mg, change in x, cos theta. And then the work done by tension, there, it's going to be tension, change in x, which is the height, change in x cos theta equal to change in ek. I'm going to put 0 there when I'm substituting. So the friction, what is the amount of friction? Are we given the friction here? What are we given by the friction? The air resistance there. So what is we're calculating the work done by the air resistance. So I was not supposed to do this here. So we're calculating the work done by friction here. Right? That's what we want. So we'll say work done by friction is equal to, we substitute the mass. So it's 1680, we are here, and it's negative. And the displacement is 20 meters. 20 meters. And then the gravitational force is in opposite direction. So it's going to be cos 180. Cos 180. Minus, because we're going to transpose this to that side, so it's 17,000. It's 17,000 the tension force, and 20 cos, the tension force is in the opposite, in the same direction with the displacement, and then the change in ek is going to be 0. So when you punch that everything in the calculator, your answer there, it will be negative because it's going in the opposite direction. It will be negative 10,720 joules. And that's the work done by friction. I hope that makes sense, guys. Bye.